Hi guys, in this video I'm going to show you how to compute the cross product of two vectors. I prefer to use determinants for this computation because if you consider the formulas for the cross product, this one looks a lot easier to use if you know something about determinants, which you should, as opposed to this whole thing, which is just one long expression. So trying to memorize something like that takes you a long time. So let's go ahead and compute the cross product here. So I am going to compute U cross with V. And by the way, it makes a big difference whether it's U cross with V or V cross with U. It turns out that actually the answer is not the same. So you always have to keep the same order. Be careful with that. With the dot product, that doesn't happen, but it does happen with cross product. Okay, so in the numerator, in the first row, we're going to put it's the standard unit vectors, I, J, and K. Okay. Now, in the second row, we're going to put the first vector. So we're going to put -1, 2, 1. And then the last row, this is just going to be 3, 0, -1. Okay, so let's see if we can compute it. What we're doing is something called expansion over the first row. So the way determinants work in the 3 by 3 world, you take the first element of the first row, so this would be this guy right here, the I, and then you cross out the row and the column where this guy is. So we're going to cross out the first column and the first row. And so you're going to take the guy, the I, we're going to take it and multiply it by the determinant that remains. Now, what is the determinant of 2, 1, 0, -1? The way determinants of 2 by 2 matrices are computed is that first you multiply the diagonal elements. So this would be this guy with this guy. Okay, and then you're gonna subtract the product of the other two, which would be this guy times that. Okay, so I'm just putting dots because I don't want it to be too messy as opposed to circling it. Okay, so I go 2 times -1 and then subtract 0 times 1. Now, the ith component comes with a plus. Why is that? Because I belongs to the first row, first column. If you add them up, you get 1 plus 1, and that's 2. If the 2 is even, if the number that when you add up the row and the column where it belongs to, if it's an even number, then it comes with a plus. However, when we start moving on to J, because J belongs to first row, second column, which is odd, the J comes with the minus because 1 plus 2 is 3, and that's an odd number. So this is important to remember that the Jth component is negative. Okay, so now let's see if we can cross out the row and column where J vector is. So we're going to cross out this guy and this guy. What will remain? Okay, so this will be this -1, and that's going to be multiplied by that -1, right? And then this is going to be subtract the other two. Okay, so let's do that. So we'll get -1 multiplied by -1, subtract 3 multiplied by 1. Okay, we're done with Jth component. Let's move on to the Kth component. For the K, because K belongs to first row's third column, 1 plus 3 is 4, and that's even, so K comes with a plus. Okay, what's going to be left? So if I were to cross out, let me see if I can find some pale color here. So if I cross out the row and the column where K is, then I'm going to wind up with what? Well, I'm going to wind up with this -1 multiplied by 0, and then subtract this multiplied by that number, right? Okay, so we go -1 multiplied by 0, subtract 2 times 3. All right, so let's simplify that. So the I will be -2. Okay, the Jth component will become 1 minus 3. That's -2, but because this was negative, that's actually going to be plus 2J. And finally, the Kth component, because this is -6, will be -6K. So the next thing we do is we're going to write it using components because I always prefer component form to IJK. So this is -2, +2, and -6. I will always insist on you checking your answer. Is that really correct or not? And how do you do that? Well, think of the u cross with v as some vector w. This vector w must be orthogonal or perpendicular, whatever you prefer, to each of the original vectors. So if you find the dot product of that vector with each of the original vectors, it should be 0, because remember, if the vectors are perpendicular, the dot product must be 0. So let's take u, which is -1, 2, 1. Let's dot it now with our answer, -2, 2, -6. And let us see if that's going to give me a 0. So let's see. So this is going to be 2 times 2, and then plus 1 times -6. Okay, so this is +2. So this is 2. Then I get 2 times 2, which is plus 4. And then I subtract 6. Okay, so this looks like that's 0. Okay, great. Check. Now, do you also have to check the other vector? So we just checked that u and w are orthogonal. What about v and w? So the answer is yes, you do have to check, because sometimes one of them works, but the other one doesn't, especially if you have zeros in proper places. So now we're going to take v. Okay, so what was v? V was 3, 0, -1. And we're going to dot that with -2, 2, -6. Okay, let me kind of separate this here. Also, let me move the graph a little bit below. Okay, so then what will happen? I get 3 multiplied by -2 plus 0 multiplied by 2 plus -1 multiplied by -6. So this would be -6 plus +6, and that's 0. Okay, so I check. What that tells me is that this answer is correct.